Hey guys, Mr. Marone here. Welcome back in. Hopefully you guys had a wonderful break and we are now back and ready to work now that it is the new year. If you're watching this and it is not the new year, I apologize for getting your hopes up. But we're going to take a look today at a couple of relationships within triangles when we draw in specific types of lines. So we're going to look at two different ones. We're going to look at perpendicular bisectors and angle bisectors and then see what that does for us here. So before we do that, we're going to just define a concept called equidistance. It's just a really fancy way of saying of equal distance or the same distance from something. So a point that's the same distance from two other points is known as to be equidistant from them. And that comes into play when we deal with perpendicular bisectors. So we've talked about these. We've actually constructed these back in September. And now we're going to look at what it means for us when we look at triangles. So when we've got perpendicular bisectors, so here it tells us that if a point on the perpendicular bisector is sitting there, then it's equidistant from the endpoints of the segment. In other words, if I were to draw in line PQ here, and it is perpendicular to my segment, and it splits it into two congruent parts, then anywhere this point sits is going to cause these two sides to be the same distance away. So in other words, I could draw this again, and I could draw X and Y, and draw in my perpendicular bisector here, and it's got perpendicular there, and I've got my two congruent parts here. Anywhere along this line that I place point P, I could put P right here, and that distance would be the same for X and for Y. I could also put point P here or even here. No matter where I put it, those are going to create the same distance. And so it works both ways, that if I've got this perpendicular bisector set up, then we're going to have our congruent segments here and here. And if I were given those congruent segments, then we can automatically know that these are going to be congruent here, the two parts on my bottom, and I'm going to have perpendicular lines there. I want to show you a proof of this, just so we're comfortable. So it's a short proof. So if we're looking at this setup here, what I'm going to aim to do is prove that these two triangles are congruent. And once I've done that, I can say that PX and PY are going to be equal. So if we look closely at this, we know that PQ is congruent to PQ. Right? That was our reflexive property. And we know if they told us that this is a bisector of XY, that tells me that XQ is congruent to YQ. And that's by the definition of a perpendicular bisector. And we know that angle XQP, this angle here, is congruent to angle YQP by the same reason, definition of a perpendicular bisector. So once I have those pieces of information all set up, I can say that triangle XQP is congruent to triangle YQP by side angle side. And since I know that those are going to be congruent, then I automatically know that PX is congruent to PY by CPCTC. So it's a little bit of what we just did just to showcase that. Now, what that gives us is the ability to do a little bit of solving, like we have here. So in this picture, they gave us that AC was perpendicular to BD, that right angle indicates that, and because BC and CD are the same length, that tells me that AC is a perpendicular bisector. And what that automatically tells me is that AB and AD are the same measure. So it allows us to say that 6x minus 10 equals 3x plus 2. Go ahead and solve that quick, pause the video, and when you come back in, the answer will be there for you. Okay, welcome back in. So as you can see, I worked down and I found that x equaled 4, and then by doing a little bit of plugging back in to get the value of AD, I got AD was 14. So by knowing that you've got this bisector piece and the perpendicular piece allowing us to solve those other sides is really the main application for a perpendicular bisector for us. The other type we're going to look at are called angle bisectors. And an angle bisector says that if I split an angle into two congruent pieces, then any distance from the two outside parts of my angle, my two legs of my angle, to that bisector are going to be the exact same distance so long as they create right angles. So in this picture here, if I've got this picture and I've got angle bisector and I've got right angles at these little lines from my side of the angle in, that means these are going to be congruent. And the same thing is true. If I've got that same distance between this line, that means it has to be an angle bisector. So it opens up the ability to do some solving as well. So if we look at this picture here, we were given congruent angles down here. And we were given a right angle here and a right angle here at K and M. That tells me that I have an angle bisector. That tells me that JL is my angle bisector, and so it allows me to say that these two are congruent, or that 2x plus 3 equals 4x minus 11. And we're going to do the same thing that we did up top. We're going to end up just solving this out and then plugging back in because they want KL. So we'd have KL equals 2 times 7 plus 3, so we'd have 17 for KL. So there are two terms that you've heard, perpendicular bisector and angle bisector. We're now just using that within our context of triangles to help solve problems. If you have any questions, please bring them into class tomorrow, and we will take a look at them then. Have a great night, guys. Bye-bye.